In computing, images are stored and represented in two primary ways, as bitmap images or vector images. These methods differ significantly in how they capture, save, and display visual data, each suited to particular types of applications. Bitmap images, also known as raster images, are made up of a grid of pixels, where each pixel represents a single point of color in the image. Vector images, on the other hand, are created using mathematical equations to define shapes, lines, and curves, rather than relying on individual pixels. Bitmap images are saved by recording the color information for every pixel in the grid. Each pixel is represented by a binary code that encodes its color. For example, in a black and white image, a single bit can represent each pixel, where 0 corresponds to black and 1 corresponds to white. In more complex images, such as those with grayscale or full color, each pixel requires more bits to encode the available range of shades or colors. For instance, a color image with 24-bit depth uses 3 bytes per pixel, with 1 byte each for red, green, and blue intensity values. When saved, bitmap files include this grid of pixel data, along with metadata about the image's dimensions and color depth. Vector images are saved differently, as they do not rely on pixels. Instead, they store instructions for creating the image, such as the positions of points, the curves connecting them, and the colors used to fill or outline shapes. Because these instructions are mathematical, vector images can be scaled to any size without losing quality, making them ideal for applications like logos, icons, and illustrations where precision and scalability are important. Common file formats for vector images include SVG and EPS, while bitmap images are typically saved in formats like JPEG, PNG, or BMP. In bitmap images, each pixel's binary code directly determines its color, and the quality of the image depends on 2 key factors: color depth and resolution. Color depth refers to the number of bits used to represent the color of each pixel. A greater color depth allows for a wider range of colors and more detailed gradations. For example, an 8-bit image can display 256 colors, while a 24-bit image can display over 16 million colors, providing much more realistic and vibrant images. Increasing color depth enhances the richness and subtlety of an image, but also increases the file size. Resolution, on the other hand, refers to the number of pixels in the image grid, typically measured as pixels per inch, PPI, or in terms of total pixel dimensions, such as 1920 x 1080. Higher resolution means more pixels are used to capture finer details in the image. For example, a high-resolution photograph will appear sharper and more detailed compared to a low-resolution version, particularly when viewed closely or printed at a large size. However, increasing the resolution also results in larger file sizes because more pixel data must be stored. Together, color depth and resolution determine the quality and realism of a bitmap image. While increasing these factors improves the visual fidelity, it also demands more storage space and processing power. For applications requiring detailed and realistic visuals, such as digital photography or graphic design, high color depth and resolution are essential. By contrast, for web graphics or mobile applications where file size and speed are critical, optimizing these parameters to balance quality and efficiency is key. Both bitmap and vector approaches have their strengths, and their use depends on the context. Bitmap images excel in capturing intricate detail and complex textures, making them ideal for photographs and realistic artwork. Vector images, with their scalability and precision, are better suited for designs that require clean lines and adaptability. Together, these technologies enable the creation and use of images across a vast range of digital and physical media.